In this video, I'm going to show you how to take an absolute value function like this and rewrite it as a piecewise function. I'm going to show you two different methods. First, I'm going to show you a shortcut for how to do it without graphing, but then I'll go back and show you how to do it with graphing. So first, the shortcut. Look at this equation. We have y equals -2 times the absolute value of x minus 2 plus 2. I can find the two pieces of my piecewise function by treating the absolute value sign as parentheses. So I'm going to do this twice. I'm going to do it once with a +2 and once with a -2. So it's going to go like this. So first I will have y equals -2 times x minus 2 plus 2. And then later I will do y equals +2 times x minus 2 plus 2. This is going to give me the two pieces of my piecewise function. So let's follow through on this. So this is going to give me y equals -2x plus 4. Right, I'm doing the distributive property, so I'm getting a +4 plus 2, and then that's going to give me y equals -2x plus 6. So this is one piece of my piecewise function. So now with a +2, this is going to be y equals 2x minus 4 plus 2. So that'll be y equals 2x minus 2, combining like terms. This is the other piece of my piecewise function. All right, so in other words, if I want to write a piecewise function, it's going to look like this. F of x equals, now here comes my pieces. All right, so I'm going to have -2x plus 6, and I'm going to have +2x minus 2. The only thing missing is I need the domain that goes with each piece. All right, how do I get the domain? So I will have to think a little bit about what the graph looks like, but just really briefly. Absolute value, I know that absolute value functions will make a V shape. But because this one has a negative in front, I know that this will be an upside down V shape. All right, another thing I know is that the vertex of this V is going to be +2, 2. How did I know that? I'm getting that from this and this. Okay? Thinking of our transformations, this x minus 2 means it's a shift to the right 2. So that's where the x value of 2 is coming from. And then it's up 2. This is right 2, up 2. So that means 2, 2. All right, so I do need this basic image in my mind to help me with the domain. So look, -2 slope. That means the downward sloping side. So this is actually the -2x plus 6 is the right-hand side. This is the upward sloping part, so that's going to be the +2x, all right, the +2 slope. So the 2x minus 2 is going to be the left-hand side. Now, the x value where it changes from one function to another is right here. What is the x value here? Well, this is x equals 2, all right, because of the x value right here. So it's going to be one function less than 2. It's going to be another function greater than 2. So the negative 2x plus 6, that's going to be for x values that are greater than or equal to 2. All right, because this is the right-hand side. And this part over here is to the left. That's going to be for x values that are less than 2. Notice how I made one of them greater than or equal to, and one of them is just less than without the equal to. It doesn't matter which one has the equal to, just pick one. So that's the answer. That's the short way. Okay? Let me just mention, if you like interval notation, x is greater than or equal to 2. Another way to write that is to say 2 to infinity. All right, that's the interval notation way of doing the same thing. X is less than 2 would be negative infinity to 2. All right, and to capture the equal to part, I use the square bracket. And to show that this one is not equal, I used round parentheses. Anyway, this is the answer. And that's how you can do it without really graphing. Now, I'm going to go back and do the same thing again, but this time I'm going to do it with graphing. We should get the same exact answer. Okay, so I'm going to graph. I'm just going to be a little bit more careful. I'm still going to use the fact that I know that the vertex is going to be 2, 2, as I already explained. So I know that the vertex is going to be 2, 2. Okay, now because the slope is, looking at this negative 2 right here, that gives me the slope of the right-hand side of the v, basically. So this says down 2 over 1. So from the vertex, I'm going to go down 2 over 1. All right, so that is going to give me the right-hand side of this absolute value function. Now the left-hand side will just be, it makes a v, it's symmetric. So this side is going to be going like this. All right, I'm just doing the mirror image. I'm going down to left 1, mirroring this. Okay, so I'm going to have this red side of the graph doing like this. So, now here's where I make the two pieces of my piecewise function. So I have f of x equals, and I'm getting ready for my two pieces. Just think y equals mx plus b. I think I'll do the red part first. What is the equation of this line? And this line really keeps on going, right? Forever. What is the equation of this red line? Well, thinking about y equals mx plus b, the m is the slope. Clearly, this has a slope of 2. All right, positive 2. It's going uphill. So this would be y equals 2x. And then what about the b? The b is the y-intercept, which you can see right here. So that's 2x minus 2. So that's why my first piece is going to be 2x minus 2. All right, now let's go ahead and say the domain of this piece. This piece is happening to the left of 2. So the domain is going to be x is less than or equal to 2. All right, now let's do the blue part. And again, I'm thinking about y equals mx plus b. The blue part has a slope of negative 2. All right, I pulled that right off the function in the first place, but it's a slope of negative 2. It's going downhill. So that gives me y equals negative 2x. Now, the b, the y-intercept, I have to extend this line until it hits the y-axis. So that would be like boom and boom. I'm carefully going up 2 over 1, up 2 over 1. So I make sure that it hits exactly at the right spot. So I see that the y-intercept is here at 6. So that's negative 2x plus 6. Sometimes this method is a problem. If I extend this line and it goes way off the graph, sometimes it's hard to figure out exactly what the b value is. But in this case, we can easily tell that it was 6. So that's why this piece of the graph will be negative 2x plus 6. And the domain, it's going to be this part of the graph to the right of 2. In other words, x is greater than 2. So this is the answer, and you can see that this is exactly the same as what we got the other way.